Hello student. Today in this session we are going to discuss about the quarter wavelet, and this is the topic of the Donere University Physics paper 4th, and this is the session number 6 of the topic under the topic of polarization. By the way, I am Dada Firias from Government Degree College, Chennagiri. Today let's discuss about the quarter wavelets. As you know that it's a retarder. Retarder means it changes the state of the polarizations of a light. So usually the wavelet or a retarder is the optical device, and that can alter the changes the polarized state of a light wave traveling through it. So on this way, usually they have a two types of wavelets we can be seen. One is the off wavelet and another one is the quarter wavelet, and also there is includes full wavelet also there, but for now we study only these two plates, half wave plates and quarter wave plates. Half wave plates we already discussed in the previous session, and today in this session let's we discuss about the quarter wave plate. Usually half wave plate will be shift the polarization states of a linearly polarized light. So whereas the quarter wave plate is can convert the linearly polarized light into circularly polarized light and circularly polarized into linearly polarized light, and also it produces the elliptical polarizations as well. So this is quarter plate is just made. Let you see the quarter wave plate. In this picture you are seeing the quarter wave plate. When this linearly polarized light will pass through this slit, that is a wave plate, it is a changes the linear polarized light into circularly polarized light. So what is the quarter wave plate? The plate of a doubly refracting uniaxial crystal. Usually the wave plates are made up of from the uniaxial crystals, which it cuts it such that its optic axis is parallel to the cutting edge of the surface of the crystal of a quarter wave plate, such that whose thickness is such that to produce the phase difference, thickness ಹೇಗಿರಬೇಕಪ್ಪ ಅಂದ್ರೆ phase difference should be pi by 2 ಇರಬೇಕು, and their path difference is lambda by 4, ಅಂದ್ರೆ quarter of the wavelength ಇರುವಂತ between the ordinary and extraordinary rays ಮಧ್ಯೆ ಇರುವಂತ such a plate is called quarter wave plate. So quarter wave plate is a just a doubly refracting uniaxial crystal that's made up of quasi calcite whose refracting faces are cut parallel to the directions of the optic axis, and the thickness is made such that it produces the phase difference of pi by 2 and or a path difference of a lambda by 4 between the ordinary and extraordinary. That is called the quarter wave plate. After using this one, so totally the quarter wave plate is the depend upon the thickness of the quarter wave plate that's to be needed. So we need a derivations for the thickness of a quarter wave plate. So on which factor is depend upon, let me see, let d be the thickness of the quarter wave plate as we see, and mu naught and mu be the refractive indices for the ordinary ray and extraordinary ray. So then for normal incidence, the path difference introduced between the ordinary ray and extraordinary ray is given by d into mu naught mu 0 mu o minus mu e, means refractive index of extraordinary for negative, for the negative crystals. For positive crystal just mu and mu o is just interchange their path. For positive crystal we can be write d equal to mu e minus mu naught for the positive crystals. So then, but the saying that the quarter wave plate which produces the path difference of lambda by 4, that's the quarter of the wave plate, that's the lambda by 4. Especially if you consider for negative result, d equal to mu naught mu is equal to lambda by 4, and this d is equal to thickness is lambda by 4 into mu naught mu o minus mu e, that is the It's only depend upon the thickness is refractive indices differences and wavelength. It does not depend upon the order of incident like this. So is the quarter of the 1 by 4th of this value. This is similarly for positive crystal. If you use it for positive crystal, d equal to mu naught e minus mu naught is lambda by 4. That is d equal to lambda by 4 into mu e minus mu. So what the use of this quadruplet? Just they produce and detect the circularly and elliptically polarized light. This helps to detect. That's why quadruplet can be very useful for the detections of this circularly and elliptical polarized light. If the plane of polarized incident on the plate with vibration making an angle 45 degree with the emergent light is circularly polarized light. If the plate is incident on 45 degree to this quarter wave plate, it produces the circularly polarized light. So in this way then we can be easily find it. But how can it produce the elliptical light? When this elliptical light is the phase angle should be 2 n pi, means it may be 0 angle, or it may be 2 pi, means 0 360, like this way multiples of this 360. This produces the elliptical polarized light is except this angle. Sorry, the emergent light is elliptical except when del is equal to this one, means 0 2 pi 4 pi 6 pi, like this. Then its value does not produce elliptical. This except these angles they will all angles. So as we see the quarter wave plate or some other plates, these are very useful in optical mineralogy. So when you use this optical mineralogy, the sensitive tint or full wave and quarter wave plates are widely used in the field of optical mineralogy, and they are used in a petrographic microscope. That's make the polarizers makes an easier of the optical identifications of minerals in the sections of the rocks. You can't be see every object can be to keep in mind that after seeing this you can particular, but it can be easily see that using this quarter wave plate it can be easily say which type of the minerals is present in that one. So in particular allowing detections of the shape and orientations of the optical indicatrices within the visible crystal sections. Those are very useful for the applications of the quarter wave plate. As we study in the previous sessions, and this in these sessions is the of a plate and full wave, sorry, quarter wave plate. That's very useful for us to applications. That's why I hope you will understand and what is the of quarter wave plate, how we derive the equations of thickness of a quarter wave plate. That's enough for this sessions. Okay, thank you very much.